All right, guys, so I'm going to go over this physics review for your test, and I'm going to try to explain it as well as I can while also not taking too much time. So let's just go ahead and start. So number one, a motorcycle and a truck are traveling along Interstate 20 from Dallas. If the motorcycle moving faster than the truck, how do their distances compare after the same length of time? Well, I would think that if a motorcycle is going faster, okay, it would cover more distance in the same amount of time. Okay, so faster, the velocity equals more displacement. And kind of bear with my handwriting here and stuff. I'm writing on a tablet, and I don't have good handwriting anyway. B, how do their times compare after both reaching Shreveport, Louisiana? Okay, so I would think if the motorcycle is going faster, okay, it's going to get there a lot quicker. So faster the velocity equals less time. So the less time it takes to actually get there. Okay, so those are kind of self-explanatory. 2, if a car's displacement is increasing every second, what is happening to the velocity? Okay, so now this is kind of depending on how much the displacement is increasing by. So if the displacement is increasing by a consistent amount, our velocity would be constant. Okay, so velocity is constant. And looks like my pen's kind of jacking up here, so let me see if I can fix that. Okay, so velocity is constant if my displacement is increasing the same amount. Okay, if my displacement was actually increasing, so meaning I'm covering more and more ground every second, then I would be accelerating. But for this question, we're just going at a constant velocity. Number 3, a car drives 30 kilometers east, 2 kilometers west, and 15 kilometers east again. Okay, so watch out for your directions here. Okay, so when we give directions, that's usually a hint about something. Okay, so letter A, what is the distance? What distance did the car travel? Okay, so remember, distance does not care about direction. So like your odometer in your car measures distance. Doesn't care which way you went. Okay, it just counts how many miles you actually went. So for distance, we would simply add all these numbers. So 30 plus 2 plus 15. Okay, and that gives me 47. So 47 kilometers. Now part B, it says, what is the car's displacement? So displacement cares about direction. Okay, so that means if you have directions and they conflict with each other, I can't just add them together. Okay, so if I'm going 30 kilometers east, so 30, and then I turn around and I go 2 kilometers west, I'm going to have to subtract that 2. So 30 minus 2, but then I turn around and go east again, so I'm going to add that 15. Okay, so 30 minus 2 is 28, plus 15 gives me 43 kilometers. Okay, so those would be my answers. C, if the trip lasted 0.5 hours, what is the car's speed? Okay, so watch out. So speed uses distance over time. Okay, not displacement. Velocity, in part 2, velocity uses displacement over time. So displacement is characterized by that little triangle, which is delta D. Okay, so for speed, we use distance over time. So my distance is 47. So that means I'm going to carry that 47 down here. So speed equals 47 divided by 0.5 hours. Okay, so 47 divided by 0.5 gives me 94 kilometers per hour. Okay, so that is my speed. Okay, velocity uses displacement. So I'm going to take this 43 and I'm going to bring it down here. So 43 divided by 0.5, okay, and that gives me 86 kilometers per hour. So a little bit of difference there. Okay, so just watch out for those. D, convert both of your answers in part C to meters per second. Okay, so the trick to going to meters per second and kilometers per hour is knowing your conversion number. Okay, so over here to the side, I'm going to kind of show you real quick. if I want to go from kilometers per hour to meters per second, you divide by 3.6. And if I want to go from meters per second to kilometers per hour, I would multiply by 3.6. Okay, so that's not something we're going to give you, so that's something you would need to know. Okay, the way I remember that is if I'm going from hours to seconds, okay, so I would think it would have to be a smaller number. Okay, so because you had an hour to cover all this distance and speed, velocity, okay, versus a second. So a second should be like a snapshot of that, so it should be smaller. Okay, so let's convert our speed from here. So we're going to bring our answer from part 1 of C down to here. So our speed is 94 kilometers per hour. So 94 divided by 3.6. So 94 divided by 3.6. Let me get my calculator. So 94 divided by 3.6. Give me 1 second. So 94 divided by 3.6 gives me 26.1 meters per second. Okay, velocity. So we're going to take our answer from part 2 of the last question. So I got 86 kilometers per hour. Okay, we already know that, so let me just get rid of that. Okay, so 86 divided by 3.6. So 86 divided by 3.6 gives me 23.9 meters per second. Okay, so don't forget these conversions right here. Just makes it a lot more simple. Okay, number 4, a train leaves the station at the 0.0 meter marker, traveling with a constant velocity. Okay, so the way I like to do these problems is I like to label. So it just told me my velocity there. How many seconds, so it means T is my question mark, will it take for the train to pass the 1620 meter mark? Okay, so I'm doing velocity, and then that is my displacement that it gave me. Okay, so velocity, displacement, and time. So our only equation that uses those right now is velocity equals displacement over time. Okay, and I am looking for seconds. So velocity is 36. Displacement is 1620. And I don't know time, so I'm going to leave it as t. Okay, so this is where I see a lot of algebraic mistakes is when you have an exponent on bottom, people think that we should multiply 1620 times 36. That is not the case. Okay, so if you have something that you're looking for on the bottom, just simply switch these two. So that's the same as saying t equals 1620 divided by 36. Okay, so just switch them. So 1620 divided by 36. 1620 divided by 36. And I get 45. So that means it's going to be 45. Oh, my pen stopped working. So 45 seconds. Okay. Number 5, suppose the train from question 4 travels for 1 hour. What will be its displacement in both meters and kilometers? Okay, so I know my velocity is in meters per second. Okay, so 36 meters per second. And we're starting to deal with kilometers now, and we're dealing with hours. So I'm going to go ahead and convert this to kilometers per hour. So remember from back at the top, if I want to go from meters per second to kilometers per hour, I would multiply by 3.6. So 36 times 3.6. And let's see what that gives us. So 36 times 3.6. That gives me 129.6. So 129.6 kilometers per hour. So now I know my velocity, I know my time, okay, and we want to know what is displacement. So that is my question mark. Okay, so I'm going to set it up in my equation. So 129.6 equals displacement over time. My time was 1 hour. Now I can multiply both sides by 1. Okay, so my displacement would be 129.6 kilometers. So that's the first part of my question. And it also asks for meters. Okay, 1 kilometer equals 1,000 meters. Okay, so if my answer is already in kilometers, then all I'd have to do is multiply by 1,000. So 129.6 times 1,000 gives me 129,600 meters. So those will be both my answers, 4 or 5. Number 6, at 1 p.m., a car traveling at a constant velocity of 94 meters per second west, okay, and it is 17 kilometers to the west of your school. How far away from the school will it be at 3:30 p.m.? Okay, so at 1 p.m. I left, 3:30 p.m. I arrived, so my time would be 2.5 hours. So that's my first thing. Okay, and I have a velocity of 94 meters per second. Okay, now if I look, my time is in hours, okay, and my velocity is in meters per second. So I'm just going to convert that to kilometers per hour. Okay, so I'm just going to multiply by 3.6, and we'll see what we get. So 94 times 3.6, that gives me 338.4 kilometers per hour. Okay, so now I have my velocity and my time. So now I can plug into V equals d over t. Okay, so I'm just going to use velocity equals displacement over time. Okay, so I'm going to give myself a little more room and clear that up. So velocity is 338.4 equals my displacement, which I don't know, so I'm going to leave it as that. Okay, and my time is 2.5 hours. So now I'm going to multiply both sides by 2.5 to get d by itself. So 338.4 times 2.5, and that gives me a displacement of 846 kilometers. Okay, so that would be if I started at the school. Okay, but it told me in the beginning of the problem that I was already 17 kilometers west of the school. So all I'm going to do is add that 17 to the 846, and that'll tell me how far I am from the school. So 846 plus 17, that gives me 863 kilometers. So west. Okay. Number 7, a plane travels 460 kilometers per hour for 1.25 hours, slows down to 300 kilometers per hour for 1.1 hours, and then speeds up to 500 kilometers per hour for 0.75 hours. What is the average velocity? Okay, so real quick, average velocity equals total displacement over our total time. It gave me velocities and times. It did not give me displacement. So that means I have to find my displacements for each one of those velocities. Okay, so what I'm going to do is I'm going to erase this and give myself some room. Okay, so I need to find the displacement for each segment of this trip. Okay, so my V1 is 460 kilometers per hour. I'm just going to zoom in a little bit. Okay, and my T1 equals 1.25 hours. Okay, and I'm looking for my displacement. Okay, well, I know velocity equals displacement over time. Okay, so 460 equals my displacement over time, which was 1.25. Okay, so what I would do is multiply both sides by 1.25. So 460 times 1.25 gives me 575. So my displacement one is 575 kilometers. Okay, so I found my first displacement. So now I got to do the same thing for each other segment. Okay, so my next segment, so V2 equals 300 kilometers per hour. My T2 is 1.1 hours, and I don't know my displacement. So my D2 I don't know. Okay, so velocity equals displacement over time. So like the last one, all we did was multiply velocity and time. So 300 times 1.1 gives me 330 kilometers. Okay, so if you need to see that again, just rewind a little bit and you can see how I got the first one. So now it means I got to do part 3. So V3 equals 500 kilometers per hour. And then my T3 equals 0.75 hours. So I'll just multiply 500 kilometers per hour, okay, times 0.75. So 500 times 0.75 gives me 375. So my displacement 3 is 375. Okay. So now in order to find my average velocity, what I have to do is I have to add up all my displacements and all my times and divide them. Okay, so my V average equals 575. Let me zoom in and make myself so I can write a little smaller. Plus 330 plus 375. And that's all over my total time. So my time was 1.25. So 1.25 plus 1.1 plus 0.75. So I'm going to get my whole number on top, get my whole number on bottom, and just divide them. So that means let's see what we get. So 575 plus 330 plus 375. Okay, gives me 1280, and I'm going to divide that by 1.25 plus 1.1 plus 0.75. And so that means my average velocity would be 412.9. So I'm just going to say, oops, pin came off. So that I'm going to say it's 413 kilometers per hour. Okay. Number 8, what does slope represent on a position versus time graph? Slope always equals velocity. Always. Okay, on a position versus time graph. So number 9 was the main difference between a vector and scalar. Okay, so vector has direction. Scalar, the way I like to think of scalar is if you step on a scale, it gives you a number. It does not tell you how much you weigh in a direction, it just gives you a number. Okay, so scalar has no direction. Okay, number 10, define the following terms and include whether they are a vector or scalar quantity. Okay, so distance is total distance covered. Okay, so this would be scalar. Okay, so if I drove to Walmart and back, stuff, again, my car does not care about direction, it just counts the distance. Okay, so your odometer goes up, doesn't care about the direction. Now displacement is where you ended versus where you started. So it is your final position minus your initial position. Okay, so if I went to Walmart and it's 10 miles away, okay, and I drove back, my distance would be 20 miles. But if I went to Walmart, which is 10 miles away, and then I came back home, which is 10 miles back, technically my displacement would be 0 since I ended up at the same place that I started. Okay, speed is distance over time. Oh, I'm sorry. Displacement is vector, so it cares about direction. Speed is distance over time, so distance, which is scalar. Velocity is displacement over time. and that is a vector. Okay, number 11, describe the differences between constant velocity, average velocity, and instantaneous velocity. So constant velocity, okay, just like it sounds, covering the same amount of displacement over time. Okay, so that means it's not changing. So that would look like just a straight line going up or down on a graph. Okay, average velocity is the velocity between 2 points. Okay, so it's the velocity between 2 points usually on a graph. Okay, so it's what your final velocity is, average with your initial velocity. Okay, instantaneous is velocity at a particular moment. So that means I want to know what is the velocity at that exact moment. Okay, so again, kind of bear with my handwriting here and stuff, so it's not too good on this iPad. Okay, so let's go look at some graph stuff. So number 12, use the graph above to answer the following questions. At t equals 3 seconds, which cyclist is ahead? How do you know? So at 3 seconds, if I go up, okay, I would simply look at who's further on my y-axis, because my y-axis, sorry, laptop kind of moved. My y-axis is position. Oh, that's awful. Let me rewrite that. So position is my y. Okay, so I would simply see is who's further ahead in my position. So that means cyclist, whoops, technical difficulties. Okay, my cyclist A is further ahead. Now, which cyclist is traveling faster at 7 seconds? How do you know? So remember, slope equals velocity. Whoever has a steeper slope has a higher velocity. So if I look up, oh, I'm sorry, I actually messed up on that last one. So let me fix that. So it was actually B was further ahead. So my mistake, I was looking at the next question. So B, which cyclist is traveling faster at 7 seconds? So I would simply look at who has the steepest velocity. Okay, so A has my steepest velocity. C, are their velocities equal at any time? How do you know? Okay, well, their slope is never the same. Okay, so no. Okay, slope is never the same. Slope never the same. D, what is happening at the intersection of A and B? Okay, so their velocities are never the same, but at 5 seconds, they are at the exact same position on the y-axis. Okay, so that means they are at the same position. So that means they met each other. Okay, so let's look at our next graph. So 13, the graph above shows the motion of 4 different cars. Does car A have a positive or negative velocity? Okay, so if I am going up, that is a positive direction, which is a positive velocity. So I'm going to say positive. B, how does car B's velocity compare to car A's? Okay, so they both have positive velocities because they're going up. So they're both positive. But if I look at their slopes, B's is a lot slower. Okay, so B's velocity is slower. Okay, C, which car slows down? So let's look at, we've already looked at A, we looked at B, so let's look at C. Now a curved line, if you look at this curved line, so if we see it's going up here, okay, I am covering less and less distance over a longer period of time. Okay, if I was speeding up, it would look like this. That's if I was speeding up because I'm covering more and more distance over less amounts of time. But if you look at C, it's actually rounding off to a flat line. Okay, and flat lines, remember, tell us it's basically no velocity. So let me just get this out of the way so I can not confusing you. Okay, so if I'm going towards becoming a flat line, that means I'm slowing down. So that means car C is slowing down. Which car has a negative velocity? So the only one we haven't talked about so far is D. Since it is going down, that is a negative velocity. Okay, so that is car D. Do any of the cars change directions? Okay, so on this one, they don't actually change directions. Okay, for to change directions, you would have to go positive and negative or negative then positive. So A, for it to become change directions, it would have to turn around and go down. D would have to go up. C would have to start going the other direction. And B would have to start going down. Yeah, so none of them actually change directions. Okay, so let me just go ahead and erase that so no confusion. Okay, no change in directions. Okay, so let's move on to this question here. Okay, I know it's a little bit blurry. So 14, use the graph above for the following questions. What is the starting position of the object? Okay, so if I'm starting, it looks like I'm starting right here at 0. Okay, so that would be 0 meters. That's where I started. What is the position at 2 seconds? So all we're looking at is the y, where they are on the y at 2 seconds. So if I look at my 2 seconds, so 2 seconds would be right here. And if I look over to the left, my position would be 6 meters. Okay. C, what is the velocity of the object at 1 second? Okay, so 1 second, we would need to find the velocity. So that means we're looking right here. Okay, so this would be an example of instantaneous velocity. When you have a curved line and I ask for instantaneous velocity, okay, you would draw a tangent line like the one that's drawn here and just find the slope of that line. Okay, so your tangent line simply bumps up to the point. It doesn't go through the line, the curve, it just bumps up next to it. Okay, so you can have varying answers here. Okay, but when you want to find the velocity, the instantaneous velocity on a curved line, just draw a tangent line that bumps up to that point. So part C, it says, what is the velocity at 1 second? So I'm going to find the slope of this line. Okay, so this is my x2, y2. And I'm going to look over here. And I'm going to say this is my x1, y1. Okay, remember, anytime I want to find the slope, it's always, so slope is y2 minus y1 over x2 minus x1. Okay, so it's a little hard for me to see these. So my y2 looks like it's 7.5. And my y1 would be, I'll just say 4.4. Okay, so these can vary. Okay, or 4 point, because it jumps up by 2. I'm going to say 4.8. Okay, so these can vary a little bit as long as we can see that you're doing it right. Okay, x2, that is simply 2 seconds over my x1, which is simply 1 second. So 7.5 minus 4.8 gives me 2.7 over 1. So my velocity would be 2.7 meters per second. Oh, there's that little decimal. So 2.7 meters per second. What is the velocity at 4 seconds? So at 4 seconds, I want to know what is the velocity here. Okay, so this is simple. We already know this point here. So all I need to do is find the slope of this line. So I just need 2 points. So this slope here would be 5, 4. And this point here would be 3, 6. Okay, so remember it's y2 minus y1, so my slope, my y2 would be 4, my y1 would be 6, my x2 is 5, and my x1 is 3. So 4 minus 6 over 5 minus 3. So 4 minus 6 gives me negative 2 over 5 minus 3, which is 2. So this would be negative 1 meters per second. Okay, so remember it's always your final position minus your initial. So this 5, 4 is my final, or my x2, y2. Okay, and this is my initial position, or my x1, y1. Always final minus initial. That's how I get a negative number. Okay, letter E, what is the velocity of the object at 6 seconds? So at 6 seconds, I want to know what is the velocity here. Okay, so don't tell me 0. That would be my position at that time, but I still have a slope. Okay, so I need 2 points to find this line. So luckily for me, I already have this point right here. And I'm just going to pick this point right here since it's on the nice junction. Okay, so that is at 7 seconds. And that is at negative 4. Okay, so 7, negative 4. So now, let me do some erasing because I don't want to confuse you. Now this becomes my initial. And this becomes my final. Okay, so slope is going to be negative 4 minus 4 over 7 minus 5. So y2 minus y1 over x2 minus x1. So negative 4 minus 4 gives me negative 8. 7 minus 5 gives me 2. So negative 8 divided by 2 gives me negative 4 meters per second. F, what is the velocity of the object at 8.5 seconds? So at 8.5 seconds, I'm right here. Okay, if I have a flat line, okay, I have no slope. And no slope means no velocity. So my velocity would be 0 meters per second. So there's no slope. G, what is the displacement of the object from 0 to 6 seconds? So from 0 to 6 seconds. Okay, so let me just tidy this up a little bit. Okay, I got a lot of writing going on. Okay, so from 0 to 6 seconds, so at 0, my position was 0 meters. At 6 seconds, my position is 0 meters. Okay, so my final position minus my initial position. Okay, so final position minus my initial position. So that would be 0 minus 0, okay, which gives me a displacement of 0 meters. Now my distance would be different if I definitely went places, but I ended back at the same position after 6 seconds, so my displacement would be 0. H, what is the displacement from 0 to 8 seconds? So we already know my starting position was 0, and at 8 seconds, so at 8 seconds I'm right here. My position is negative 10. So it's always final minus initial. So negative 10 minus 0 gives me negative 10 meters. That's it. I, what is the average velocity from 0 to 8 seconds? Okay, so I would want to know what is the average velocity from 0 to 8 seconds. So I would need to basically, and forgive me on this line, it's probably not going to be that great. I would basically have an imaginary line that connects these 2 points. Okay, so all I need is 2 points on this line to figure out what the slope is, the average velocity. Well, luckily this first one is simply 0, 0. The point here, I'm just going to choose the point at 8 seconds, would be 8, negative 10. Okay, so again, it's always final minus initial. So my slope is y2 minus y1, so negative 10 is my y2. My y1 is 0, so negative 10 minus 0. x2 is 8. x1 is 0, so negative 10 over 8. So negative 10 divided by 8. Let's simplify that. And I get 1.25. So negative 1.25 meters per second. So all you have to do for average velocity is simply connect the 2 points. Okay, and then find the slope of that actual line. So letter J, what is the average velocity of the object from 0 to 10 seconds? Okay, so now I would basically draw another line connecting these 2 points. So now I need to find the slope of that line. Well, my initial was 0, 0. And this part would be 10. And if I look at my y, it's a little bit blurry, but I believe that's negative 6. So my y2 is negative 6. Okay, so m equals, my y2 is negative 6. Okay, minus 0. And my x2 is 10. Minus my initial x1 is 0. So negative 6 over 10. Okay, so if we're going to simplify that, that would just be a negative 0.6 meters per second. Okay, letter K, what is the difference traveled from 2 to 10 seconds? Okay, so from 2 to 10 seconds. Okay, so from 2 to 3, I didn't even travel any distance. Okay, and then, so let's look at our line here. So from 3 to 5, I travel 2 meters. And then from 5 to 7, I go from 4 to negative 4, so this would be 8. Okay, and then from 7 to 8. Okay, 7 to 8, so I'm starting at negative 4 and at negative 10, so this would be 6. I don't travel anywhere here, so that would be 0. And then I go from negative 10 to negative 6, so that would be 4. So what I would simply do is add those up. So 2 plus 8, 2 plus 8 plus 6 plus 4. Okay, 2 plus 8 is 10, plus 6, 16, so that gives me 20 meters. Okay, what is the average speed of from 2 to 10 seconds? Remember, speed is distance over time. We just found our distance in letter K, so 20 over my time, which is 8 seconds. So 2 to 10 would be 8 seconds. So 20 divided by 8 gives me 2.5. So 2.5 meters per second. So remember, distance does not care about direction. So we have no negative numbers there. You just simply add. Okay, what time interval is the object slowing down? Okay, so remember, if I am approaching or becoming a flat line, that is me slowing down. Okay, so the only time I'm slowing down or speeding up is when we're dealing with a curved line. Okay, when you do straight lines, you're either not moving at all or you're going at a constant speed. So the only time I have a curved line, which I'm actually turning into a flat line, is right here. Okay, so that means from 0 to 2 seconds, I am slowing down. Okay, my slope is getting flatter. So 0 to 2 seconds. What time interval is the object not moving? So that means I'm looking for a flat line. Okay, so if I look, I see from 2 to 3 seconds, I have a flat line, and 8 to 9 seconds flat line. So 2 to 3 seconds, and 8 to 9. That is the only time I'm not moving because they are flat lines. What time interval is the object moving in the positive direction? So I'm simply looking for something that's going up. Okay, so even though I'm slowing down, 0 to 2 still has a positive velocity. I'm going up. So 0 to 2 has a positive direction. And then I don't go positive again until 9 to 10, so right here. So from 0 to 2 and 9 to 10. So 0 to 2 seconds and 9 to 10. What time interval is the object moving the negative direction? So I'm looking for any time I'm going down. Okay, so pretty much from 3 all the way to 8 seconds, I'm going down. It changes velocities, but I'm going down. So 3 to 8 seconds is when I'm going down. So that's when I'm moving the negative direction. So 3 to 8 seconds. Last question, what time interval is the object moving the fastest? So I'm looking for the steepest slope. It does not matter if it's negative or positive. Okay, I'm just looking for steepest slope. And if I look at this, at my line, I'm looking for the steepest slope. So that means from right here would be my fastest slope. So that is from 7 to 8 seconds. So again, it does not matter if it's positive or negative. Okay, you're just looking for the steepest slope. So that would be 7 to 8 seconds. And that's it.